Hey everybody, this is Mr. Munson, and I want to give you a few notes on exponent rules. And this is basically when you're dealing with exponents. Now, if I was you, I would have a place in either in the front of my book, maybe a couple, 3, 5 pages where you're just slowly adding in rules and properties and things like that that you need for a quick reference. Or maybe this is in the back of your book where you leave the last 6 pages for you to quickly to go back there and see how you're supposed to operate with certain rules and properties of algebra and things like that. All right, let's get started. First up is the product rule. What it says is that if I have two numbers, or if I have a number that's the same number and you're multiplying them, and one's raised to one power, let's call it m, and another one's raised to another power, n, you just simply add their exponents. Next up, the quotient rule. If I have a number raised to a power and I have the same number raised to an n power, and they're being divided as I have there, you can see this is the same thing, just expressed in a different format than this one. You take this and it basically comes to the conclusion of the number raised to the power of m minus n, the numerator minus the denominator. Next up, power to power rule. If I have a number raised to a power and then that is raised to a power, then I can rewrite that as the number raised to the product of the two powers. Next up, power of a product rule. If I have two numbers being multiplied being raised to a power, that's the same as each of the numbers being raised to the power of themselves, still being multiplied. Next up, power of fraction rule. When I have a fraction being raised to a power, that's the same as the numerator being raised to the power and the denominator being raised to the power separately. Next up, zero exponent. Anything raised to the zero power is equal to 1. Negative power. When you have a number raised to a negative power, it can be reciprocated and put the exponent in the denominator to make it a positive exponent. The same is true if you have a number in the denominator, a negative exponent, you can move it to the numerator's position to make it a positive exponent. Next up, fractional exponents. When you have a number raised to a fractional exponent, it can be rewritten as a root problem. where the number is raised to the numerator, where you're taking the nth root of that number.